talk a little bit about what that meant to us. Distance on the number line. This is 0 on the number line. Always positive. We talked about that. So here's the formal definition. The absolute value is actually a two-part definition. When you take the absolute value of something, it is just itself if it's a number bigger than or equal to 0. Does that make sense to you? The absolute value of 5 is 5. But what if the number is less than 0? It's the opposite of itself. And this always freaks people out because they look at this and say, wait, this is what? How can the absolute value equal a negative? Well, it equals a negative if the original number is already negative. That's how you make it positive. So that's your definition. Underneath there, I put down some properties of absolute value. I think those are pretty self-explanatory. Now we're going to talk a little bit about distance on a number line because we're going to start doing some absolute value problems a little bit differently. So just for a second, if I said to you, how far apart are 4 and 7? You would say 3. And how did you get 3? You subtracted. And if you subtract 7 minus 4, you're good. You could also subtract 4 minus 7 as long as you took the absolute value. So on the number line, distance is the absolute value of the difference. Okay, that's not a hard concept. Just think about that for a minute. The absolute value of the difference. That's distance on the number line. Subtract them, take the absolute value. That's how far apart they are. So, if our numbers are A and B, then the distance between A and B is either this or this. Period. That's the distance between A and B on the number line. Now, how does that translate into solving problems? Well, let's look at this one and see. I am 100% sure that if you found this problem in the hallway, you would split it up into 2 pieces and say x minus 4 equals 5 or x minus 4 equals -5. Am I right in that assumption? That's how you would do it. There's nothing wrong with that. Things get very sticky, however, when you have more than one absolute value in the problem or if you have multiple variables in the problem. So I'd like you to think about this just a slightly different way, right? You can always, by the way, on these hard problems, you can always use your definition too. But the distance between 2 numbers on the number line is the absolute value of their difference. What do I have right here? The absolute value of a difference. So this says that the distance between some number and 4 is 5. So here's 4. The distance between, let me put x out here. The distance between those 2 numbers is 5. So what does x have to be? If that distance is 5, x would be 9. But wait, x could be over here. This is still 5. What would that be? -1. So the answers to the problem are -1 or 5, or 9. Isn't that exactly what we would get if we solve these 2? All right, let's try the next one. Same thing. Use the number line when you do it. distance. Now this said the distance between x and 4. Okay? What does this say? Be careful. Got it? The distance between x and negative 2. Remember, distance is a difference. You gotta be subtracting. So adding is subtracting the negative. So now I've got negative 2, and I need the distance to be 6. So where would this be? If that's 6, this would be at 4. And if this is 6, this would be at negative 8. Now be careful, it's not an equals this time. I want the distance to be more than 6. So if I need to be more than 6, I am out here or out here. Did you agree with that? These are the points where I'm exactly 6. These are the points where I'm more than 6. So my answer, negative 3, 8, 4, 4, 2. I am not telling you, and will never tell you, how to do a problem. So if you don't want to do the problem this way, that's okay. I just want you to be aware of that because calculus depends on limits, and that idea is in the definition of the limit. So I just want you to at least be familiar with it. Okay, whether you do your problems that way or not, that's up to you. All right, number 5, we gotta do this though. Write as an absolute value the distance between x and 6 is 7. We're going to write something like this. The distance between x and 6 is 7. What do you think?
Absolute value. So x minus 6 is 7.
Equals 7. Yeah, that's it. This says the distance between x and 6. Remember, distance is the absolute value of a difference, subtraction. Alright, the distance between negative 3 and x is less than 5. What's that one look like? X plus 3 is what? Less than 5. Perfect. Beautiful. Beautiful. The distance between x and negative 3. So x minus negative 3. The distance between x and a is at least d. The distance between x and a is at least d. What do you think that looks like? X minus a.
Greater than or equal to.
Perfect. Beautiful. Magnificent. Midpoint on a number line. That's so easy. How do you find it, the midpoint on the number line? Can you just average them? So you're going to add them and divide by 2. So for C and D, that would just be C plus D over 2. What would it be for 6 and negative 9? Negative 3 halves? Keep an eye on my arithmetic. How about negative 2/3 and 7? Don't freak out because there's a fraction involved. Negative 2 and 21 would be, 19/3. But then you have to divide that by 2. So did you get 19 over 6 as your midpoint? we just did was on the number line. Now we're going into two dimensions. Anybody remember the distance formula? We gotta know how to find distance and midpoint. Anybody remember it? Someone talk. Okay, we get it down because you gotta know it. X2 minus x1 squared, y2 minus y1 squared. Does that look familiar? That's your distance formula. And then what about midpoint? Midpoint is the same as it was a minute ago, only those x's and y's. So how do we find midpoint? We add them up and divide by 2. So how do we find the midpoint in the coordinate plane? We take our x's and add them, and our y's and divide by 2. So we average. Midpoint is average. Okay, so right now with your partner, try problem 8. You're finding the distance and the midpoint, or 8A. For 8A, find the distance and the midpoint for those 2 points. Do it with your partner. See what you can come up with. Now remember, I hear some conversation out there. When you're subtracting, the order really doesn't matter because you're going to be squaring the answer. So I wrote in my formula x2 minus x1, but in my math I did x1 minus x2. It doesn't matter because when you square, subtraction is key. The order doesn't really matter. I did it fast. I got root 10, right? And then I got 1/2 7/2. Is that right? Okay, you good with that? The next problem has decimals in it. Guys, that doesn't change a thing. So let's try this one. I think that's just 20.5. So let's try that one. Do your arithmetic. You got this. project today, I have a feeling I probably did this there. What do you think? How does those look? Okay? Charlie? You good with that? All right, distance and midpoint, really, really important stuff. All right, number 9. Find A. By the way, this notation right here, when you just see CD with nothing around it or anything, that means distance. That's the distance from C to D. That's what that notation means. All right, so what have I got? I've got point A, I don't know. Point B is 2, 4. And M, which is the midpoint, is negative 3, 6. And I gotta figure this out. Ideas? Yeah.
Double both the numbers of, or both the coordinates in M, and then subtract B out of it.
Okay, so tell me that again.
So the negative 3 and 6, you double them, and then subtract B,
Negative 6, 12.
and subtract B out of it, so subtract 2 out of the negative 6 and 12 as well.
So that would be negative 8. Right? And then 8. Okay. I don't know, is that right? I don't know. Negative 8 and 2 is negative 6. Divided by 2 is negative 3. 8 and 4 is 12. Divided by 2 is 6. Sounds great to me. Wasn't what I was thinking about, but it worked. Anyone have a different strategy? By the way, what he did was this is how you find midpoint, right? Just the X part of it. So he said, I don't know what this is, but I know that if I add it to 2 and divide by 2, I need to get negative 3, right? So see why he doubled? Solving that equation is going to equal that doubling, and then subtract that number. So he did that formula, I'll just kind of use that. Here's how I would do this problem, take it or leave it. I think it's fun to look at problems different ways. I know in getting from negative 3 to 2, at midpoint to endpoint, I know that I would travel in the X direction 5 steps. So guess how far I have to go to this endpoint? Back 5. So negative 3 minus 5. And then 6 to 4 is back 2. So I need to go ahead 2. That's how I need to go. But that's fine. What he said was fine. As long as you got that answer, okay? All right. Find the area and perimeter of triangle CHS within these coordinates. All right, let's do perimeter first. I might just plot these. Alright, so here's my triangle, not very well drawn, but you get the idea. And I'm going to need the perimeter. What does perimeter mean? Distance around? So that means I'm going to find all these sides and add them up. So what am I going to do? I'm going to find this side. This is 20 off. And this is 20 off. And this is 20 off. Okay, let's go. You go, I'll go. Let's see what we can find. changed it?
Yeah, what happened? I just read my list.
Sorry about that. Welcome to the sauna. I got two of them that match. Did I do that right? So I guess another question could have been, prove that the triangle is isosceles. Right? But I need the perimeter. So before I do that, anybody have a problem with any of these? Everybody get Route 41, Route 41, and Route 82? So what's my perimeter? Add them all up, what do you get? We're gonna be careful, be careful. What, how do we add radicals? Can you add every radical on the whole wide world? No. What's the rule? The radicands, that is the number under the radical, has to match. So these two can be added. It's like having an x and an x. You got two of them. So I have two Route 41s plus Route 82. There's your perimeter. This problem is a little tricky. Because when we say now find the area, how do you find the area of a triangle? 1/2 base times height. But in order to have base and height, you gotta have a right angle in there somewhere, right? Base and height, they're perpendicular to each other. So you really have to kind of be on your toes here, but something special is going on. You see it? Violet?
It's a 45, 45.
It's a right triangle. Now, how do we know that? Well, what do you get if you square that? And you square that? And you square that? Is that a true sentence, true statement? And that's the Pythagorean theorem, right? And if the Pythagorean theorem works, if a squared plus b squared does indeed equal c squared, then you have a right triangle. Right? A little tricky, you have to be on your toes, but we have a right triangle, and there's the right angle because these are the legs of the 45, 45, 90 triangle. Okay? So what's my area? Well, it's gonna be easy. The area is 1/2 the base, which is Route 41, times the height, which is Route 41. So what is my area? 41/2? That one's tricky. You have to be on your toes. Alright, we're doing apartment try number 11, and then I'm gonna have somebody come up and show us what you guys did. Prove the diagonals of the quadrilateral bisect each other. friend. Let's have somebody up here figuring this out. We want to prove what was it? The diagonals.
Which proves, yeah, those proves. Does not exist. So actually, it's according to. It's fine.
All right, the boys got it figured out here. They have a strategy. Let's see if it's the same as yours. Talk loud, because the fans are your voice. Tell them what you're doing.
You just found the midpoints of both the line there.
Okay, they're up here mumbling. They're finding the midpoint. And what should happen if the diagonals bisect each other? What's going to happen? Each diagonal is going to have the same midpoint. So did that happen for you? By the way, if the diagonals do indeed bisect each other, we're figuring that out right now. What kind of quadrilateral do we have? Does it have to, I heard somebody say rectangle, does it have to be a rectangle? It could. What does it have to do if the diagonals bisect each other? Could be a rhombus. It's going to be a parallelogram, right? So it's going to be a parallelogram. It would be a rhombus if the sides are all congruent. I don't know if they are or not. It would be a rectangle if the diagonals were congruent. I don't know if they are or not. But I know since we have the same midpoint, that we do indeed bisect each other. All right, got a lot of odds and ends today. Everybody keeping up okay? Any questions about that? Good? What's the standard form of the equation of a circle? Everybody know? Again, these are just random things here. Patrick?
X minus h squared plus y minus a squared equals r squared.
And that circle has a center at
H head.
H head. And a radius of R. So, write the equation of the circle with the given radius and center. Okay, so you're going to write that equation. All right, this is pretty easy. What's that equation going to look like? X the center is -3, so what is that going to look like? X plus 3 squared, don't forget the square, and then y minus 5 squared equals 2 root 6 squared, which is what? Not 12. I heard somebody say 24, and that's right. So 2 root 6, when you square it, you got to square 2, and you got to square root 6. So that's how we get 24. So that's the equation of your circle. It has a center at -3, 5, and a radius of the square root of 24, which is 2 root 6. Right? B. What's that one going to look like? X minus 5 squared and y you can say minus 0, or actually we could get by with just y squared. Would that be okay? If you want to put in the minus 0, that's fine. Won't hurt anything. Now what's it going to equal? No idea what 9.1 squared is. 82.8. Good? Problem 14A. Now you got the circle. What's the center and the radius? What's your center for A? 3, comma, negative 1/2. And what's your radius? Square root of 18, which is 3 radical 2. Uh-oh. That was easy. Mr. Funk, B does not look like A,
Okay,
does it?
no.
No. If it did look like A, it would be easy. Can we make it look like A? Okay, what are we gonna do? Mr. Funk, do you have an idea? If you don't, it's okay, but do you have an idea?
I don't think I write one.
You wanna just throw something out there?
Can you like group together like the X's and the Y's and do like
Yep.
associate?
Yep. So we are going to move things around and group our X's together. And when I do that, I'm actually gonna leave a little blank here, because in a moment, I'm going to be completing the square. I'm going to create a squared quantity, because that's what I need. So I'm gonna have to create it. And I'll do the same thing with my Y's. And I'm going to move that 14 to the other side. Because that 14 is kind of interfering with my completing the square here. So everybody good here? Getting to here? Notice I'm going to be adding numbers to the left, so I have to add those to the right also because I'm the equation. Okay, anybody remember how we find that number? Coming back to you, Mr. Funk, if you remember.
Don't you take you would take 12 and divide it by 2 and square it?
Absolutely. So 12 divided by 2 squared is 36, both sides. Do the same thing with our 10. So 10 divided by 2 squared is 25. Now that was fun, but we did it for a purpose, not just have fun. We did it for a reason. This is a square. What square is that? X plus 6. Very good. And what square is this? Y plus 5. And all that adds up to 75. And now the equation looks just like problem A again. So now it's easy. Where is our center? -6, -5. And what's our radius? Square root of 75, we'll want to break that down. That breaks down into 5 rather than 3. All right, how do you feel about that, okay? Good, because you're going to do C right now. So you and your partner, let's do C. Don't be confused. How many times are you going to have to complete the square in problem C? Once. because there is no y term to mess it up. You got a y squared, but there's no y to mess that up. So you're only gonna have to compute the square on the x's.
I got plus two. I'm not minus two. Because when you just took these are the minus.
Yep, yep, I'm actually, so I'm feeling pretty good about it. Anybody have a question? Quick comment. Let's suppose in the problem that we just did, that plus 2 had been like a plus 7. What would happen if that plus 2 had been a plus 7 instead? What would happen? Well, you would be in heap big trouble, because this would be a negative 7 then. And what would happen right here? That would be a negative 3. And then what would your radius be? The square root of the negative, which is imaginary. There's a word for that situation. Believe it or not, that's called a degenerate. That's a degenerate conic section. Circles are one of the conic sections, along with the ellipse, the parabola, hyperbola. Did you guys do those last year? No? Circles? Maybe? Some of you did. Okay. So when they don't work out, when it becomes impossible, they're called degenerates. So that situation, you would say the circle doesn't exist. It's a degenerate. Okay. Good to know. All right, 15. All right, we're going to write the equation of a circle. So this is what we're going to write. Something that looks like this, a circle. And we have a diameter. These endpoints are 2, 7, and 6, negative 13. That's all we got. Caitlin, you're gazing intently at my board. Do you have an idea?
You could find the diameter.
So you need a distance?
Yeah.
We could absolutely find this distance. That would be a diameter. We can do that. So let's go ahead and do that. So I'm going to write diameter here, remind myself this is a diameter. So 2 minus 6 and negative 13. Goodness gracious. So what is that? 16 plus 400. Did you get the square root of 416? Now, I am sure that simplifies, but I'm not doing it. All right? I'm not doing it. I'm just leave it there for a second. And if you think ahead, I think you understand I'm not going to waste time simplifying. All right, I got my diameter. Now, Caitlin, what else do I need? What? Midpoint, absolutely. If I'm going to write the equation of the circle, don't I need the center? So the center 11 minus 13 divided by 2. I got 4 negative 3. Is that okay? So what's my circle look like? X minus 4 squared, y plus 3 squared equals, now be careful, this guy has to be r squared. What is that? That's the diameter. So the radius will be that over 2. And when I square that, I'll get 416 over 4, which is 104. So use Caitlin's idea was an absolute great idea. If anybody think about doing things a little differently, yeah, what did you think about doing?
I don't know if it'd be right, but I was thinking about, I guess, I was gonna just find a big point.
Yeah, yeah. So he says, instead of finding the diameter first, he found the midpoint first, and then found that distance. Doesn't matter, it's the same amount of work, but this way you don't have to divide by 2. Good. All right, P2 will be due on Thursday. Let's move on to P3. Properties of equality. By the way, we'll have a quiz after P5. When we finish P5, we'll have a quiz. Properties of equality. Anybody know anything about any of those? Any of those words look familiar to you? Could you write the property for any of those? Okay, these are all properties of equality, so I'm not going to write it each time, but the reflexive property of equality, the symmetric property of equality. Okay, I know you know, so I'm going to call on someone and you're going to tell me. Miss Cress, do you know any of those?
Is reflexive A equals A?
It is. Reflexive property says something equals itself. That property always makes, I was like, why in the world do we have that? But you remember from geometry, you used it a lot when you were constructing the proofs. You had to add things to both sides. Okay? All right, let's see. Mr. Babington, do you know any of these? No? All right. Learn them. Parker?
Would symmetric be like
No, but it involves 2 variables. Symmetric says if A equals B, then B equals A. Symmetric is different than commutative. Commutative says you are either adding or multiplying. A times B, B times A. That is different than equality. These are properties of equality. What's transitive then? If A equals B and B equals C, then yep, A equals C. This is a property of equality. The addition property of equality. You use it all the time. What does the addition property of equality say? If I'm an equation, here I am on a scale, unbalanced. if you put 3 pounds on this side, 2 extra pounds on this side, you're gonna have to put 3 extra on this side, right? So the addition property says if A equals B, then A plus C equals B plus C. You can add the same thing to both sides. Multiplication, same thing. If A equals B, then AC equals BC. Your question might be, well, can't we do that with subtraction? If A equals C, A minus C equals, A equals B, A minus C equals B minus C, is that true? In pure mathematics though, there are only 2 operations. There's only addition and multiplication. Because what's subtraction? Adding the opposite. What's division? Multiplying by the reciprocal, right? So we don't really have problems with those. Okay. Number 2 is just a couple definitions. A linear equation, ax plus b equals 0. Linear inequality, ax plus b is either greater than 0, less than 0, greater than or equal to, less than or equal to. Properties of inequality. There are no reflexive and symmetric properties of inequality. Think about that for a minute. Can I put a less than in there? No. Can I put a less than in here? No. So we don't have these 2. Could I put a less than here? So that is the transitive property of order, or the transitive property of inequality. How about for addition? Can I put a less than in there? If A is less than B, then A plus C is less than B plus C? Yeah, that's the addition property of inequality. Now. Same thing for multiplication. If I put a less than there, and I put a less than there. Put a star next to that one. Why is there a star there? Because there's this silly rule that says if you multiply by a negative, what happens? The sign flips. So we have to modify this. This is true if C is positive, right? Actually. That is true if C is positive. However, if C is negative, that sign switches there, doesn't it, when I multiply? All right, we're going to do one more problem and we're going to stop. I feel like I just babbled for a ton. 4A, right now, solve it. 4A. make mistakes, all right? So what did I do? I got a common denominator. You don't have to do it this way, but I got a common denominator because in an equation, as soon as you get a common denominator, you can use them. And therefore, yeah, no fractions. That look all right? All right, friends, I'm going to stop there.